PreCalc. Here we are at night school, or is it morning school for you? We're watching this after Friday's class. That's the 20th, so you'll be watching it on Friday, Saturday, or Sunday, the 20th, 21st, or 22nd. Check the date, Shannon. All right, so let's look at what we're studying for the next couple days. We're going to look at the conic sections. And conic means there's some kind of cone involved. So let's think of a cone. So I have a cone on top of an inverted cone. Something we see often in our everyday lives, right? All right, here is a cone on a cone. And it turns out we're going to slice this cone up. We're just going to take out our sharp sheets. They're really called planes. And we're going to cut right through this conic section, cone on a cone. So if you can imagine me slicing this cone right there, and I'm looking down this way, so my eyeballs are looking right down straight into the cone and enjoying every minute of it. You will see the intersection between this sharp plane and the cone looks like this. And from the perspective of the person looking straight down, that will be a circle. So that's the first conic section that we're going to study. So let's get on with it. The circle. Some things you probably come to me already knowing about the circle. So you can let me know when we finish, what you remember from your deep, bright math past. Any conic section will follow this equation: ax squared plus cy squared plus dx plus ey plus f equals 0, where x and y, what am I doing? These are all x's. Ax squared, no they're not. I got them right. Sorry about that. Had a senior moment. All right, so that's the equation for any, so this is like the general equation for conic sections. And you might say, well, what happened to B? Well, I'll mention B before it's all over, but right now you can't bear it. So you can't bear it now. So when you're all up and ready with all of these variables and constants, then I will tell you about B. A, C, D, E, and F are all constants. They're numbers, and X and Y are the variables. All right, so we're going to start with the locus definition of a circle. And I'll tell you a little bit about that word after I write it out. The locus, so the circle is the locus of all points equidistant from a given point. So the word locus is the mathematical term for location. So when I say the locus definition, I'm talking about location of the various parts. So this means the location of all points equidistant. Equidistant is the same distance from a given point. So if I have a point, the given point, then all the points that are, say we have this distance, we'll call it D, then that point is D away from that one, but so is this one, and all the points that are D away. And I'm only drawing a small sample of them, but all the points would create the circle. All right, so that's the definition. And it turns out, here is what I expect that looks familiar to you, that you've seen before. I'm not positive, but I'll teach it like you haven't seen it, but I expect that it does look familiar. All right. I'm in trouble with lighting today. I hope that's okay. All right. We are going to call the center of the circle HK. Hector and Kyle. Hector and Kyle, HK. That will represent the center of the circles. That means we're somewhere like on a coordinate plane. And that is how we get to the center. We went back H and up K. For this example, H is negative and K is positive. HK, and we're going to say that the radius of this circle is R. All right, a point on the circle, any point, I'll pick that one, I'll call it XY. We can see that the distance from HK to any XY is always going to be R. So I'm going to throw this information into the distance formula. The distance formula is an old dear friend of yours, and it's going to be x2, and you have 2 points, x2 minus x1. These are subscripts, x sub 2 minus x sub 1, quantity squared, plus y2 minus y1, y sub 2 minus y sub 1, quantity squared. This is the distance between, this is the distance formula between any 2 points. So let's plug it in for our example, because we know no matter where we are on the circle that the distance is always r. So I'll call d r. And this will be my point x1, y1. This is my point x2, y2. So I'm going to use the distance formula and sub in the points. So we have a big square root, x2, and my problem is just x minus x1 is h, and y2 is y. Y1 is K. So we're not quite in what we call standard form. The standard form doesn't have any square root in it. So I'm going to square both sides to get rid of the square root, and I'm going to switch sides. So I'm going to get, when I square this long part, I get rid of the square root. And I'm just going to put r squared on the other side. And that is called the standard form of a circle. If you're given an equation in standard form, you can easily find the center, Hector and Kyle. Hector is connected to the x value, but with the opposite sign. And that's why the negative. And Kyle is hooked to the y variable with the opposite sign. And the radius is going to be the square root of whatever is in this position, holding r squared. So let's say I give you one. See if you can pick out the center and the radius. All right. My example then, find center and radius to sketch. So we're going to find the center and radius to sketch. Alright, so x minus 2 quantity squared plus y plus 3 quantity squared equals 16/9. So this is in standard form, so I know right where to look for my center. Remember, the center is Hector and Kyle. So Hector is always situated in this position, and it's the opposite sign. Because in the formula we have negative h, and I want positive h. So whatever sign is here, I'm going to use the opposite. So my center is 2, and the first coordinate, and the y coordinate is Kyle. So it's going to be the opposite of the number connected to the y. And the radius is going to be, this is radius squared, so I don't want radius squared, I want radius. So I'll have to take the square root of that, which is conveniently situated. Taking the square root, I get a 4/3. So now I can sketch it. My center is 2 over and 3 down, right there. 2, 3, negative 3. And the radius is 4/3. That's 1 1/3. So coming out from this, I'm going to go about 1 1/3 away and create a circle. Alright, so I'll mark that as 1/4. Alright, little bitty guy there. Alright, so that's how you go that direction. What about the other direction? Suppose we have this information. Suppose I give you the center. The center is -1, 2, and the radius is square root of 20. Can you find the standard form? So write in standard form. Alright, to do that, I know it's going to follow this pattern, x minus h, Hector, Kyle. Alright, so I'm going to build from that. So I'm going to take my center. This is going to be my h and my k. According to the formula, though, I'm going to put it in with the opposite sign. So h is -1. I'm going to put it in as a +1, or you can think of it as a -1. X plus 1 quantity squared. When I get over to the y, I'm going to put in the opposite sign. And now I need to square the radius to put it in standard form. Square root of 20 squared, 20. Alright, so that's the answer right there. Alright, I'll shut this part down. I have one more important thing to say. So see you back on part 2.